Hello all. Today we are going to learn about control logic design in a hardware control of one flip-flop first state method using an example. So the steps used for designing the control logic are stating the problem, second, initial equipment configuration, third, formulation of algorithm, fourth, design of data processor part, and the last one, design of control logic. These are the steps used in control logic design. So first one is stating the problem. So here we are going to consider an example like designing a control logic of signed magnitude adder or subtractor. Signed magnitude adder or subtractor. So in such a case, the problem will be stated as add and subtract binary fixed point number represented in signed magnitude representation. So this signed magnitude representation will be represented as a sign bit followed by n-1 bit of magnitude. So it has two parts. One is the magnitude part and the other one is the sign bit. So for any addition or subtraction operation, it requires at least two operands. So the two operands will be taken in this format. The result obtained after performing the operation will also be of a signed magnitude number. It also sometimes in some operations it will be giving an extra bit. That is, after the operation, one bit will be formed which exceeds the actual bit size, and that extra bit will be called as overflow. Second step is equipment configuration. So the example we are considering is a signed magnitude adder or subtractor. It consists of, for any addition operation, it will be having two operands. So two operands will be stored in the two registers, A register and B register. So A register will be having the first operand, B register will be having the second operand, and this register will be of in that signed magnitude representation format, like n-1 bit magnitude and a single bit sign bit. So these two are registers and this forms a flip-flop. These two are flip-flop in order to store the sign of the magnitude. Okay, sign of the value will be stored in this flip-flop. For A register, it will be termed as AS, B register, BS. Operands will be taken into the ALU to perform the ALU operation. Control logic, in order to issue the control signals, it will be taking input QA, QS and X. QA in order to initiate the add operation, QS subtraction operation, and X is like the operation that is performed is terminated. So these are the requirements, or these are the configurations for the required process. And next step is like you have to formulate the algorithm. So this includes some principles, addition and subtraction principles based on the two operand values. So this many knows how this operation will be done. Like if the operation is like plus A plus B means what will be the result? A plus B. If it is like plus A minus plus B means this operation will be this subtraction will be changed to addition, taking the complement of B, and the second operand complement will be taken minus B. Again, plus say minus b means if it is subtraction, it will be made as plus and b will be complemented. Complement will be taken of the second operand. Minus a minus plus b means minus a plus complement of b, that is minus b. Minus a minus b will be equal to minus a plus b's complement is plus b. So for any subtraction operation, it can be converted to addition operation taking the complement of the second operand b. This here we are following the principle of arithmetic operation using 2's complement. So the arithmetic operation can be a true magnitude operation is there and 1's complement operation is also there. Because of the advantages of 2's complement, we are concentrating more on the 2's complement operation. So some operations here it is listed, and these operations, if the operand value is greater than or equal to a value greater than or equal to b, a less than, if it is a less than b, what is the output that is obtained while performing these operations? This is shown here. Like if it is like a plus minus b, and if the a value is greater than b means the sign will be of a. So plus, take the, since signs are different, you have to take the subtraction, that is a minus b. So plus a minus b. Once more, that is sign is different, so you have, since the sign is different, you have to perform the subtraction operation. If the sign is same, you have to perform the addition operation. These are the basic arithmetic logics. So if a value is greater than b, then sign of a will be formed in the result. If b is greater than a, then sign of b will be formed in the result. Also, subtraction will be like b minus a. Okay, so if signs are different, you will be performing the subtraction operation, and if a is, first operand is greater than the second operand, then first operand minus b, sign of the first operand will be taken. If the second operand is greater than first operand, then second operand minus a, sign of b will be taken. Sign of b will be taken. Similar is the case here also. Here two operands are having the same sign, so directly you can perform the addition giving the plus sign. But here sign is plus, so here result also you will be getting the plus sign. Now here next sign is minus, both the operands are having the same sign, so perform the addition operation. The result, sign of the result magnitude will be minus in both the cases. Any minus and plus, different sign. So what you have to do, perform the subtraction operation. So sub a minus b, if a is greater than or equal to b, it will be a minus b, and if b is greater than a means b minus a, you have to take the sign of plus b. If a greater than or equal to b, you have to take the sign of a. Next we can consider some examples which will be following those principles of addition and subtraction. So first case, let us take for a greater than b. So example, we can take a is equal to 4 and b is equal to 3. So a is equal to 4, b is equal to 3. Binary of 4 is 1 0 0. Binary of 3 is 0 1 1. Okay. Now if I have to perform the operation like 4 plus minus 3. If I have to perform the operation like 4 plus minus 3, what you have to do? 4 is a positive number, minus 3 is a negative number. So 4 you will be writing in the magnitude of A register. 4 in the form of binary you will be writing magnitude, and the sign bit will be a single bit which indicates the positive number. So for 0 will be indicating the positive number. Similarly, in case of 3, binary of 3 is 0, 1, 1. So here we are taking an example 4 minus 3. So in order to indicate it is a negative, in the sign bit of B we are putting 1. So in this table there is A register with the magnitude A and sign. 2 columns are there, magnitude A, sign A. So B, magnitude B, sign B. Then comes the result. Result sign. If there is any overflow that is there, that is the extra bit, and result magnitude of the result. So these are the columns written. So in order to perform this operation, what you have to do? Take the binary form plus minus 3. So minus 3 means you have to take the 2's complement of 3. 2's complement of 3, which is equal to minus 3's 2's complement. 3's 2's complement. What is it? Binary of 3 is 0, 1, 1. 2's complement of 3 means you have to take the 1's complement. That is, 0's will be changed to 1, 1 will be changed to 0, plus 1, 1, 0, 1. This is the 2's complement of B. Okay, but here you are taking the 2's complement. So for any operation like A plus minus B, actually it is some form of subtraction is done. So in this case, what you have to do? A plus 2's complement of B you have to take, and 2's complement of B will be like B complement plus 1. So operation is A plus B complement plus 1. This operation will be done here. So the result will be like 1, 0, 1. The result of 2's complement is 1, 0, 1. Now you have to do the addition of 4 plus 2's complement of B. That is 1, 0, 0 plus 2's complement of B is 1, 0, 1. You will be getting 1, 0, 0, carry 1. This becomes an overflow. So the overflow bit is what? 1. Overflow will be 1, and the resulting magnitude is 0, 0, 1. 0, 0, 1. Now what is the sign? Since A is greater than B, the sign register of A will be the resulting sign based on the principles. Based on the addition and subtraction principle, if A is greater than B, the sign of A register will be there in the result also. Will be same. Consider another example. So before going to the another example, you can verify the result also. So what is 4 plus minus 3? While you are subtracting, you will be getting 4 minus 3 is 1, and it will be plus 1. So here also you got the value as 1. You got the value as 1. Now what about this overflow? Since A is greater than B, overflow will be discarded. Overflow will be discarded. Okay. Now we can consider another example in which you can take minus 4 plus 3. Here also A is greater than B. Minus 4 plus 3. So what will be the result? Minus A plus B will be equal to, if A is greater than B means, since sign is different, A minus B, and greater sign will be put. This is the operation to be performed. So you have what you have to do? A plus 2's complement of B you have to take. A plus 2's complement of B. Here also you have to take this A plus 2's complement of B in order to get the result. Okay, so before that, while using this table for filling the problem, minus 4, 1 0 0, minus indicates 1, and plus 3, 0 1 1, here it becomes 0. So what will be the sign? Sign will be A greater than B. The sign will be the A magnitude A sign. So it will be 1. Now you have to find the result of the magnitude and whether there is any overflow you have to find. So to compute the result, A plus 2's complement of B, A is 1 0 0, that is 4, and second operand B is 0 1 1, that's 2's complement. B is 0 1 1, 2's complement means you have to take the 1's complement, 1 0 0 plus 1, which will be 1 0 1, 1 0 1. Perform the addition operation, 1 0 0 1. Here also a overflow has occurred. So overflow is occurred, and A is greater than B, so you can discard this overflow. One more thing I left out, that is, if an overflow is occurred and that is 1, which means that the obtained result is the true magnitude. Obtained result is the true magnitude. So filling up the table, what you can write here? Here it becomes 0 0 1, which means 1. Overflow is 1. Okay, here also, since A is greater than B, the sign bit of A register will be same as of the result, no change. Okay, so overflow, if it is 1, it indicates that the result magnitude is the true magnitude, actual value, true magnitude.